Today, I'm Amelia, and today I'll be going through assignment 5, which is a decision tree where we have to make a decision whether to go with parts for U or aim row for the plier for unipart. And so the decision tree is broken down, as we can see. MRO's spending will be 150 million in either case. And for parts for you, as you can see here, there's a commission of 5%, regardless of how much they buy. Every part is 5%. And then AMRO has a commission rate of only 1%. However, there's also a $10 million fee added on. So with that information and with the probabilities of spending in year 1 and year 2, we will make a decision based on whichever one has the lower cost. Now for year 2, there's also the discount factor, which comes out to 0.83%. To calculate that, it is 1 divided by 1 plus the discount rate, which is 0.2. So yeah, that brings us to the discount factor, which I decided to add into the cell here for easy calculations. And so we have in our first year, there's a 75% chance that the MRO spend will stay the same, so it stays at 150 million, but there's a 25% chance that it drops by 10%. So in this cell, we just simply refer to B31, which is here, and then for the 25% chance of drop, we simply put 0.9 times this to get 135 million. From there, in year 2, with the spend stay the same, there is then a 50% chance the spending stays the same again, or a 50% chance it drops. And for this scenario, where the spending drops in the first year 25%, there's also a 50% chance it stays the same, or a 50% chance it drops again. So the same calculation done again to get us 121.5 million. And then from there, we need to calculate each scenario. So this column is parts for you, year 1 and year 2. And then this column's aim row, year 1 and year 2. So, and here is the total probability of each scenario happening, which we will need to use at the end to calculate total expected costs. So in year 1, to calculate this number here, the cost, it is E21. So I have 150 million, which is the chance in year 1 of the spending staying the same, multiplied by the commission rate for parts VU, which is the 5%. So that's how I got that cost. And then in this scenario, it's the spending dropped, multiplied again by the commission rate. We don't have any discount factor calculated yet because that is only for year 2. So going down to year 2 for parts VU, we have the spending multiplied by the commission, but we also need to add the discount factor, which I've referred to here. And the same for the next scenario. So continuing down with the calculations. So I have the chance of the spending dropping multiplied by, again, the commission rate of 5%. And then because it's year 2, multiplying in the discount factor. And then the same down here, going down, we have the spending, multiply commission by the discount factor. And again, in this case, it's the spend, multiply commission, by the discount rate. So that is everything for parts for you, which is option 1, and then option 2, aim row here. It's the same thing, except we're using the commission rate of 1%, and we also need to add in for year 2 the 10 million. 10 million. So I refer to E7 here, 10 million. So going down, same thing. The spend multiplied by the 1% commission plus the 10 million spend. And here we have also included the discount factor again, because it's year 2. And going down, same thing. The spend times the commission rate and the discount factor. And so because it's year 2 here, that's why we didn't need to add the 10 million this time. We paid for that up here in year 1 only, because the 10 million is for the 2 years. After calculating all that, which I did use Microsoft Copilot AI to help me with some of the steps that I was confused on, and to verify my answers. I also just built a table down here to calculate the total cost year 1 and year 2 times the probabilities, which I put in this column, to get the weighted costs, because we need to consider the probability of each scenario happening. So 0.375, which is from over here, and multiplying that by the total costs, and then so it's the total cost times the probabilities and the weighted costs. So for parts for you, I ended up with a total of 13,101,563. And aim row here, the same thing, the total cost times the probability with the weighted costs of 12.6 million approximately. So with this answer, aim row, option 2 turned out to actually be the lower cost, despite the fee of 10 million there. So that's everything, I think. My biggest struggle was probably just calculating the total cost and the weighted cost, making sure that all was done correctly. So hopefully my answers will match some of yours. Thank you.